Okay, moved around a little bit, but we're still back on the same thing. I was talking about this slight tweak. It's about 4 degrees. I think you can just see it there in the picture, that these blades have like a little dark shadow down in there. It's a good, just try and come down a bit closer here. Look. Let's see if we can see it. Can we see it? If we look from the square, we can just see a slight taper, just slight, very little, but it sets up a face to drive from. As the fluid comes through, it intersects that face and drives, and being near a square inch, pressure over area, pounds per square inch, it would be divisible of what's actually going on, but it would still be a huge formula in itself, because once these things are all together you don't know exactly, you know. But yeah, now that's the little self-driving component, what we've found. Well, it's not self-driving, it creates power. It creates power. Now what I've realised, as I said, as we've been studying this for many years, and with other things that I've come across, it's like not mystical, more mythical things. Yep, love mythical things. Now there's a mythical thing, it's not just mythical actually, it's the flag of the Isle of Man. It's actually 3 legs running. I believe that also in the pyramids and the pictures tell stories, so it's a matter of looking for the old stories, the old sayings, and that they're all true. Now then, what's going on here is there's only 3 of these little forward drivers. The reason being, if it was all the way around, it would create a huge load on the engine. So it's good in some ways, but it makes it a little bit lazy. By having self-drivers over the load that creates thrust, and when this thrust happens, because we're going over a more square blade, we just slide backwards on it, and you've got thrust forwards at the same time. It's more like the fluid is actually being strained to flow over this edge, which really just drives it. You know, the physical nature of things is, if it feels like it and it makes practical sense in what's going on, it must be true, because it's just how it is. But there's also like a backwards vortex creation going on here, which has effect. If that can pull over here, this thing is just, wow, you know, it's like just driving itself with a storm, driving itself with a storm. Very cyclonic. Now then, I've kept the, just to let you know, the internal intake area is pretty well standard. It's just standard to this model. As I said, there's a slight little curve in here to the flap and back. You know, it's like a fish just very slightly swimming through the flow of the water, creating motion. So the fluid flowing over the form creates its own motion. Victor Schauberger told us very much in a few things that, like, the fish don't swim, they're swum, and that the birds don't fly, they're flown. Now I had a thought about that, and it just occurred to me that a good example of what already exists under that is a glider. You know, gliders, people flying around in a glider. Once you're up into the currents, you can stay there for as long as there's currents, and we're creating currents with this flat out all the time. Self-driving currents, lift currents. The other one that's going on in here, because there's a restriction here, there's actually a high-low pressure set up over the intake, so then you've also got 3 high-low pressure zones in rotation, which is going to cause rotation in itself. There's many different ways of looking at these things, but the basics are the basics. It just comes down to basic movement, leverage. This angle here is a wedge. It's a wedge. Now the wedge is one of the most powerful things there is. So the fluid drives over a wedge to drive itself. Now to set this stuff right off, I'll be back with the turbine.